see a lot of common faces. It's like almost more than half the room, right? Okay. I'll try not to bore you today. We covered a lot of ground yesterday. So just a heads up. I'll cover a little bit of common ground from yesterday, just setting the high-level device farm context, and then I'll deep dive into the main meat of what we're going to talk for this session. So thank you for being here, everyone. Thank you, everyone on the Twitch TV. So let's get started. So my name is Nikhil. I'm a senior solutions engineer with the Device Farm team. And today we're going to talk about automated testing the right way. Yesterday, we looked at what is Device Farm, what is automated testing, how can you write some tests. And today we're going to focus on, let's say you already have figured out those pieces. Now, how do you refine your art? How do you make it a second nature, so to speak? So, what we saw yesterday, let's think about it today from a developer perspective. Yesterday we thought it from both perspectives. Today is just developer perspective. Let's put that into context. You have a great idea. You start writing an app. You release your first app, or you either test your app, release it, and then start finding reviews, feedbacks that look like these. My app doesn't work. I updated it. Someone used a newer device that I've never tested on. And then you start seeing these kinds of review. Well, it doesn't work on this specific device. It doesn't work on that resolution. It used to work. Maybe the OS update failed. Something crashed. So you as a developer go to your team and say, guys, why didn't this work? And typically, you get something like that. Chances are like you'll get something like that. Oh, it worked on my emulator. It worked on my device, on my machine. So what do you do is I can fix this. You go and buy a bunch of devices, right? Now, on the face of it, you can see a lot of problems with those setup. I think we covered a few yesterday. You need power, firstly. Those devices need to be plugged in. They need to have reliable network access. Can you have stable OS updates? Even carrier settings are a type of updates. I don't think we talked about that. Basically, you see these OS updates, but carrier settings, sometimes you have a device, it just says the carrier settings have been updated, right? That's also one kind of update. Then other than those, maybe you want to do manual testing, not just automated testing. So you want to just grab a device, run something real quick. So there's a whole bunch of problems when you start going down this path. But let's ask an important question. We're talking about these devices, testing, and everything. Why do you think we want to do only real devices? Why are we getting so obsessed with real devices? Android does a pretty good job, emulator. iOS has a simulator. But why real devices? Why are we getting so much obsessed with it? Why do you think we need real devices? Can I just survive with just emulators and simulators? Do you think that's okay? Anyone has any thoughts on it? I'm sure you do. All right. What do you have on your mind? Yeah. Yep. Architecture. Yeah. 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 So Gene makes a really good point here. He said he's mentioning that the architecture of the emulators, the simulators, that can be different from the real device, then the network conditions can be different on the devices. So there are a whole bunch of points on why real devices, right? So you actually want to test on something that your customer has in their hand. There's no reason why you should guess, since this worked on this, it should just probably work on real device, right? So it's probably used to use what they're actually using. Then when we say performance, now this is a fine line. You have to be careful here because you can have emulators, simulators that are really fast and get your job done. But when you say performance, it's relative, right? You are releasing an app that's supposed to run on a device, and that is your baseline of performance because that's the underlying hardware. And so when we say that performance is faster, that means it's actually what you're supposed to get, what you designed it for. That's why you need real device. Bug replication is easy. There could be some interaction. You can imagine, oh, this bugs only happen when I unlock my device and open with Touch ID, and there it's frozen. It doesn't happen. Like, how do I emulate Touch ID on an emulator, right? So bug replication is another one. Then you want to test with real-world conditions. So how about the network? Maybe the device is on a bad 3G network, 2G network. You're walking out of the room, and suddenly, oh, app froze. So it's a real-world condition. Other real-world conditions, well, two devices were talking to each other over Bluetooth, and something happened, and oh, the connection broke. Maybe the app crashed. Those kind of real-world conditions. Then, an emulator or simulator may not have access to every single hardware component, like the sensor, proximity sensor, the battery data. There are cases where there are apps or there are applications that are designed that say, okay, this process consumed that much power, so this is my prediction on how much battery is it using. But when you're saying real battery data consumption, the truest form is you unplug the device, and you say, okay, now the app is running, what is the battery drain on this, right? And that can be only done on the actual device. That's why real device do a better job in that case. And then stuff like camera, you want to do QR code scanning or some other things. Your app may have camera, so those kind of cases. And when we say no false positives, it is if your app crashed on a real device, it was reproduced on a real device, you ran a test on a real device, there was no emulated condition where you said, well, the emulator is really good at this or really fast at this or doesn't support this hardware situation. So you're not running or chasing down some hardware specific or the emulator specific behavior. So there are those benefits on why we talk about real devices. So let's say we established that we do need real devices, right? So there is an importance there. And typically what we see is you can pretty much survive without real devices if you have to just do a quick sanity check. But if you have to really release it, then real devices become necessary. So what can you do with these real devices? Right? Let's say you went ahead and you said, well, I got the real device. You can either do a manual testing, just got my all devices, I have them in my hand, but it's slow. If you add 20 devices, you're going to just go and plug in and go through each one of them, right? And inconsistent as in, give it to two people, they will use the app in some or the other different way. It's almost like fingerprints. If you give two people to use an app, they'll have a timing difference, some interaction difference in their own way, right? So it's inconsistent. And let's say you became a little smarter and you said, well, let me write some automation tests. And what does it give you? It's consistent because there's no longer guessing, there's timing and everything is fixed. But how much can you scale? You looked at our picture earlier, it could be 1 device, 2 devices, 8 devices, 10 devices, maybe 20. You got a good USB powered machine and everything. So there's a scaling problem, right? So the benefit that something like a cloud automation testing solution brings is, if you can test on hundreds of real devices on scale, you are already leveraging the benefits of automated testing that you were doing locally, but now you're doing it on much larger scale, right? So when you try to pursue any of these paths and just do automation testing, to summarize, some of the challenges that you run into are device availability. Like, okay, am I competing with someone else for this device or this resource, even if it's in the cloud or somewhere else? Am I assured that I'm going to get a device? What if a new device comes out, iPhone XS Max, and day one everyone wants to test on it. Every single person says, let me shoot my app on that and see how it works, or does it crash? You can imagine people would be contending for the resources at that point. Then you got to figure out your automation test choices. We looked at a framework yesterday where we said, okay, how do you choose a testing framework? What are the school of thoughts, and what approach do you take? So you have to choose what type of test, or your functional test, performance test, quick sanity test. Then you have your continuous integration, which we will be deep diving today into, like how do you achieve continuous integration. Reporting and access to test artifacts comes as a product of your continuous integration. So if you're doing all of that, how do you still leverage the benefits of the reports that you may have worked really hard to get or produce? And then in the whole continuous integration world, if your builds are kicking off every single code line check-in, how do you still have reliable access to your test artifacts so that you don't just keep downloading stuff and just saying, okay, I know the Device Farm or some other service provides me logs, but how do I just get it real fast? And then all of that is, of course, goes without saying that you need test setup and control on the devices. So to summarize, how does Device Farm come into picture? Device Farm is a app testing service that enables you to run automated test or access just devices for your manual testing needs in the AWS cloud. These are real devices, again, not simulators, not emulators, not virtual devices. They're not modified on a hardware, software, or network level. These are untempered devices, not rooted device. The expectation is you walk into a retail store, buy a device, plug it into your machine, and run. That's the experience you want when you're doing automated testing, and that's what Device Farm tries to come as close as possible to. So Device Farm, with Device Farm, you can do automated testing and then remote access. Automated testing, as you already are familiar with that, is you want to run on hundreds of devices in parallel. Device Farm has over 400 plus unique devices today. And of course, there are offerings, multiple offerings. If you don't find a device that's not available in the list that we offer, which is rare, but still, if you don't find it, we can go out and procure that for you, and tell you like, hey, yeah, we can get this device and make it available for you. And manual access is basically you just want to run a quick sanity test, install the app and see how it works. So what are we going to do next? So I want to cover 3 things. Is firstly discuss ways on how do you make test a first-class citizen. Have you ever noticed that tests are often the ignored part of a lot of things in development? Like, oh, why do I need to write tests? It's okay. Like, oh, fine, we'll cover it. We'll get to it later. It's not something like it gets a first-class citizen treatment. Like, okay, yeah, test is necessary. There are frameworks where we say test-driven development, where it works backwards from tests. Like, you first write the test case, and then you develop, what's necessary to meet that interaction. But not everybody follows that. And so as a matter, what happens is only the seemingly important feature-related tests get tested. And then we're going to just go over Device Farm real quick on a high level, and then we're going to deep dive into CI/CD integration. So if you think about it, what do you think needs to happen for someone to say, okay, test is important? If you had a team, say, for example, and you want to say, well, we should test, but what do you think happens with the dev when he tries to write the test, or the QA team, right? Any thoughts on what might be lacking, why they don't go for test, or there's a resistance to not write test as they should be writing? Any thoughts? Do you think tooling might be one of them? Like, how do I run this? Like, would I need to get a device, plug it in? Like, how do I access? Sure, you have this infrastructure, but how do I run this? Is there a setup that I need to do? That might be one, right? Second is, I'm inside my IDE, I'm a QA person, say, for example, or dev person, and I'm writing this test code, I'm writing this app. And from there, I say, well, I have an emulator, it's pretty simple, play, and it's there, but real device, like, okay, well, how do I do this configuration? Again, the same problem, plugging in, tooling, how do I get access? What if I just want to change a device? Do I need to walk over somewhere and ask someone for the device, or request a device? What do I do? Then there's also the question of, sure, I got the test results running and everything, but where are they running? Are they running on my machine? Are they running on some local machine? Do I need to pull data? Do I need to have connection? Can I just not initiate it and just walk away and it does its thing, right? And then CI/CD integration. If you knew that you're writing tests and they're automatically just picked up and are running on a daily basis or every code check-in, it becomes easier, right? CI/CD integration. And then it increases your confidence in, well, yeah, this app quality is getting better. So those are some of the points on how do you make. So if you had access to CI/CD integration, a simpler access, if you had better access to tooling, and if you could access or use any device on the demand, on the fly really fast, it's an impetus that, okay, these things are figured out for me. Now all I need to focus is on just writing the test. That's it. Don't bother me with the infrastructure, maintenance, configuration. Just let me focus on my test. So you can reduce a lot of time with that. So let's talk about, before we jump into CI/CD integration with Device Farm, let's talk about how does Device Farm deal with automation testing. So on a high level, you need 3 things. You need your app. This could be a hybrid app, native app, pure web application. That's input number 1. You take that. You take your tests. That may be written in any one of the testing frameworks that you choose. If by any chance you don't have a testing framework, Device Farm has its own quick sanity testing framework, fuzz and built-in, and they can run a quick test on your app. And you upload these 2 artifacts to Device Farm, choose your devices that you want to run tests on, and Device Farm will run them in parallel, give you the results, and if you want, give you a detailed test report. If you already have your detailed test reports, it will let you access those exactly as how you get access to them in your local machine. So let's just run real quick in the console and see how that works, or how that looks, just what we talked about. So let's go to Device Farm here. So I'm in the main AWS console. If I go there, can you guys see it? And then Device Farm lives under mobile services, so Device Farm. So what you see is a layout of cards. Each card is essentially a project. Project is just a collection of test runs. Test runs is nothing but one execution of your entire test suite against multiple devices. So let's use an existing project that I created yesterday, and then, as you remember from the slide, automated test or remote access. So let's do today, also let me show you remote access. So what if you just want a device real quick inside the browser, right? So if I say remote access and say start a new session, now here, you'll see a list of devices. So you'll see a lot of public devices, and then a lot of devices with lock symbol. So when I say public devices, it means that if I selected, let's say, this iPad Air 2, there will be multiple instances of this device type with that OS version behind the scenes. So it's not that it's just one iPad Air. There will be multiple ones, and multiple customers use the same device type all the time. So let's say I select that. The difference between that device and the one that has a lock symbol is private device. So private devices, a customer tells us, hey, you know what, I want this particular 5 instances just for myself. I don't want to share or compete with anyone. I need it on a daily basis, I know it. So we'll go out, procure them, and associate it with your account so they're not available to anyone, not visible to anyone but yourself. And you get a lot of flexibility with that. You can control the behavior of the device, like, do I want this device to reboot after I'm done? Do I want to clean up selective apps on this device? Do I want to maybe manage these devices saying, hey, team A gets 2 devices, team B gets 3 devices, that way. So, yeah, question. Yeah, so the question is there an additional cost to make a device private? So private devices are priced differently than the public devices. The way it is that public devices, either you do pay as you go, so you use for N number of minutes, you pay by the minute, or you get an unlimited usage model. You pay a monthly flat subscription fee, $250, and that means you get a slot. And that slot can be used with any device of any type at any point. And it will run, you can run on that unlimited number of time. And then, in the next run, you can change it. Private device, it goes by the retail cost of the device. So essentially, we have a translation template that we can share, and that essentially means that if the retail cost of a device falls in a certain margin, we say that translates to some X amount per month. So it starts as low as $200 per month, and depending on the device type, it caps out at a maximum of $500 per month. But then you get automated testing, you get remote access, you get features like VPC. You may have your device wanting to talk to the desktop under your desk. So a device in the cloud talking to that thing. You can have that connectivity feature in there. Moreover, all the features that I was saying where you see real-time availability of the device, you can manage those devices. So there are a ton of devices. And then we can even update the OS version on demand. So if you say, well, it's been on iOS 11 now, iOS 12's out, update it. And we can update that for you. So does that answer the question on the price? Yeah? Yeah. So the question is that if you use the device for a certain time period, then what do you do after that? So essentially, private devices do work for a minimum of 6 months. So there's a minimum 6-month commitment. And then if you want to change the device, you're free to change it after that. So you say, oh, after 6 months, I want to swap my device for something else, you're free to do that. And you can add devices at any point. So that's how it works. Yeah, so it's a good question. So the question is, does the Amazon have enough devices? So what we do is we monitor what devices customers are using, right? So as I said, maybe a new iPhone got released, everyone tries to use that. So we try to have an analysis saying, okay, this is the number of runs we're seeing on this device type. Do we need to scale up? Or maybe some device was really popular a year ago, but something happened and now it's not so popular. So we try to scale down in that case. So we do monitor this actively, and we have our internal, alarms and matrix, and that they tell us that, hey, this device needs more capacity, and then we scale up. So I think we're pretty good at detecting and then adding capacity as we see. But yes, so far we have not hit a case where, well, there aren't just enough devices. What happens, worst case is, say every customer using a popular device type, there might be a wait time for a few minutes, right? It's like anywhere between 1 to 5 minutes, what we typically see. But when we look at that pattern, there's room for a customer to also go with private devices, right? Like, I'll have my small subset of private device as a backup, and then my public I can dig in anytime, right?
Yeah, I was wondering, since once we go CI/CD, then why should you
Available, yeah. That is a good question. So the point was that, if you go with CI/CD, you can't risk, like, is the device available? You don't need to do a guesswork, right? It should be available. So the cleanest answer there would be, like, private devices is the most predictable way today. Like, if you see here, I have one private device, right? It shows available. There's no guesswork there. Just like, that's the exact instance, it is available. If it was in use, let me see if there's any device that's in use. No. So this is a shared fleet that I have. So, other devs might be using this. But yeah, that would be the most predictable way today. Yeah, so the question is it available in other countries? Device Farm is a service available globally. However, all the devices are physically located in the US West 2 region.
Yeah, but in other countries, they may have different phone number,
yeah.
different system.
Yeah.
That might be required for the application.
Right, so the question is, what about the device state or the configuration? Like, it may require a network or other things. So some distinction, the devices do not have a cellular connection on them. They do have we put a SIM card, but there's no cellular connection. And that goes back to the point of having a network isolation. Because imagine you have, like, thousands of devices and people calling and ringing and all that stuff. It's isolated on network level that you don't even get reception in there. So they're all the network conditions that you can emulate, they're all through Wi-Fi. Like, the device has its own Wi-Fi. So let's start a session here. And I'll let that go and keep running. And meanwhile, let's quickly do an automation and then jump to CI/CD. So how do you do an automation run? Again, the slide says 3 things. Select an app. I already have an app that I had uploaded. If not, you can just provide it from here, and then it will upload it. So I select an app. I say next. Then I choose a test type. So I'll say, let's say I wrote Appium tests. So I upload a prepackaged Appium test here. So I'll go GitHub sample, and that's my prepackaged test. I'll say upload. And then once the upload is complete, I have to choose, like, how do I want to do the runs? Do I want Device Farm to do the heavy lifting for my reporting, or do I already know what I want to run, how I want to run, and what dependencies do I need? So the benefits of having these 2 ways of execution is, in standard mode, you would only choose, as we recommend to customers do it if you don't want to do any reporting whatsoever. And you want Device Farm to do all the heavy lifting for you. In custom mode, we provide a default way of running, and for most customers, you don't really need to change even a single line of code. You can just, like, say next, next, and go. Just to give you an overview, what this is, it's a YAML file, a test spec file. Really not complex. Like, you'll see a lot of stuff written, but it's all comments, most of it. Like, the essential lines are hardly like 5 or 6. But what it is simplicity wise, it's a collection of commands. Like, consider it like a shell script, that if you had to run it sequentially, that's what this is. So if you just put shell commands in here, like, see, export Appium version. So if I just wanted to, like, export Appium version and change it, pretty simple. Just uncomment those 2 lines, done. My Appium version is changed. This is what you would do in terminal, right? You would say AVM, switch Appium version, and that's it. It does it for you. So it has phases, like you could install stuff in one phase. You could do pre-test. You could issue it some commands before your test starts, like export class path and other commands. start a server, we start the Appium server here. Then the test command actually invokes a test, so it initiates a test like this Java command. And then what do you want to do after your test is complete? That goes into post-test. And if you had some reports or any other thing, you can tell us what directory did you use to store the reports, and we'll go out and fetch those. So let's just use the default one and say next. So here's where you can choose your devices. Either you can go with the top pool that's curated list of devices, depending on three things. Mostly what customers are using, what customers are asking for, and what are the most popular devices. So those are the three main factors, along with some other that go into deciding what devices get shown up here. If you want to create your own device pool, just go here, and that's where you see all the public device offering of devices. So I can choose a few devices like OS X, maybe running LG, or maybe a Nexus device, I don't know, running 7. Here you go. Maybe a Samsung device running 8. There you go. S9. So let's just select those three. Let's say SF Loft. Save. My device pool is saved. I say next. Few configuration items. You can tell where your app. If your app needs some extra data, you can store that here. If you need multiple apps to be present on the device while the test is running, you can specify those. The radio states, whether you want Wi-Fi on, off, Bluetooth on, off, NFC, you can specify the start radio states. The latitude and longitude, which is essentially mocking the location. Think about a banking app or a cab sharing app that, find me the ATMs near it. If you want to simulate that, just give it a latitude and longitude, and it will mock that location on the device. If you had files that got generated on the host machine or on the device after your test is done, then you tell us where are you storing those, and we'll go and fetch them for you. You can change the language on the device, and you can change the network. So you can simulate the network conditions, like a 3G network condition or a bad Wi-Fi condition. And so you can either choose one of these or just create your own if you want. Say next. That's just the review page. We say confirm and start. Now, you saw the flow that we did in console, right? Now let's keep that flow in mind and then switch context to CI/CD. Like, how would you do CI/CD, right? So in CI/CD, one of the most popular ones that we hear about from customers is Jenkins. Pretty popular. A lot of customers just use that by default. That's what we hear. But that's not the only choice. There's Travis, there's Bamboo CI, other things, and many popular other ones. So Device Farm, you can work with Device Farm in both of them. Let's start with Jenkins. How do you do Jenkins? Let's see how simple this is to just install Jenkins plugin, right? So I'm in a local Jenkins plugin here, local Jenkins run. I want to first download the plugin, right? So I say manage Jenkins. Of course it logged me out. Log in again. Now we are talking about a plugin. So Device Farm hosts a plugin, a default plugin in the Jenkins repo. So we are going to look for that plugin. So I say manage plugin, and I have it installed here, but if this was your first time, you would just go here and say AWS Device Farm, and it would show up here. You would check that and say install. That's it, plugin installed, right? Now you need to tell the plugin what AWS account to use, right? You want to connect that to the AWS account. How do you do that? Again, manage Jenkins, and you say configure system, because your Jenkins instance, some part of your Jenkins system is talking to an AWS account. We say configure system, and then we go all the way down because we have this plugin installed, and what it asks is access and secret key. So if you had an AWS account, you can create users, or your default account will also have an access key and secret key, and then you can apply those here. Save, done. Step number 2, the plugin is ready to go. You can take any project now that already generates test app and then put that into CI/CD integration. Now let's see, how can you make that work? So I pick a project. So I have a test project over here. This could be any project. So let's configure that, and now let me show you what's in there. Basically, there's nothing in here. It's a completely blank project. Let's say you have your own complex way or simple way of building this, pulling it from Git repo, and eventually the output, what you're looking for is either an app file or your test output, right? You build your test. So both of them will be the output. So for Device Farm plugin to start, for you to use it, That's the starting point. So it's a build step, right? So all of your projects in CI/CD will have a build step already figured out that you're building it, and you're adding Device Farm as a post-build step. That okay, everything's ready, go now. So how do you do that? Go all the way down, and Jenkins will show a post-build action, right? So you say run test on Device Farm, and essentially it's going to open this UI, which is going to say post-build action. Now remember our console flow? Shows me all my projects. Inside that project, shows me all the device pools that are present in the project. And then your application would be wherever this Jenkins instance stores your APK. Like when it builds, it has its workspace. It's going to just put the app in there, and you just can reference it here. Then here's some interesting parameters that are really specific to DevOps. And then you don't find that in the console. So see those checkboxes, the 3 checkboxes? So essentially you say, store tests locally. So I'm just going to skip to the second one because the first one is run on unmetered slot. So as I mentioned earlier, if you're going for public devices, unlimited usage, you do the $250 per month. That's your slot. So you can tell it. Like, you can do a mix and match. You can say, well, for this load, run it on slots. For the other, don't. So store test result locally. What does that do? Now imagine you are able to use this, and you have thousands of tests, and they generate like gigabytes of data, maybe. You don't want to go and download every time to Device Farm console, right? It's cumbersome. And if you had a team that doesn't care where you're running it from, all they know is Jenkins is their endpoint, and that's where they see their results. You don't want to have them go into a login thing. It could be a federated AWS account, and they need login and all those things. You can just pull all that data. So the plugin will pull all the output data off your test and say, hey, it's available locally. Don't go anywhere. All of it is here. So you can checkbox that. The third one, this is a really neat one. So mobile testing by its nature, no matter how good we become at or how stable we use or claim the testing framework is, you can get really close to perfection, but it is a flaky venture at times because devices are not predictable. At times they will act, and they do act weird. Even the device that you daily use, even if it's the latest and greatest, at times it doesn't respond. Oh, it doesn't unlock. Why is it not recognizing me? Oh, why is this taking a few seconds to load? The Wi-Fi stack resets, and then TCP, takes its 30-second sweet time to reset the network and everything. So it's flaky. My point being, devices can be flaky at times, even if your test is 100% predictable. So most successful customers, what they do, they take an error percentage. They say, well, I'm running my test day in and day out every single code check-in. So if I'm running 1,000 tests a day or 1,000 runs, I'm going to say, for example, 98% of my runs are good, then it's good. 2% could be device issues. And most of our referenceable customers include Zillow, Zynga, Tableau. These guys, that's the approach successful customers take, that, hey, I'm going to run a lot of tests, but I'm going to stick to an error percentage, saying if it's within that range, I'm good. So when you check that box, what Device Farm does is it looks at whether there was a known device issue on that device when your test ran. And if it's a device issue, it's just going to filter that out so that it doesn't bombard you with false negative. It says, oh, it's a test failure. And you're going to go in, spend time looking at it, and all it turns out it's a device issue. Like the device just, it was a known behavior. So it detects those and filters those out for you. Other than that, it looks exactly like what the console had. You choose your testing framework over here, and then tell it where the file lives. You choose your execution environment, as we saw in the console, standard and custom. All of the radio states, the extra data, your locations, the same way as you see in the console. Really nothing new here. And then you just save, right? Done. So we are ready to schedule our first run. So let's go to that project again. And ideally, this would be on a code check-in in an ideal world. But let's say I do build now, right now, just a manual trigger. So while it's running, let's go on that and see what it's doing. So in the background, it's doing the same steps what you do in the console. So no matter where you consume Device Farm from, it's going to follow the same flow. Upload your app, upload your tests, choose an environment, and do that. So it's doing the same thing. See, it's uploading the app to S3. Then it's uploading the test to S3. Once the upload is complete, it's going to trigger a test. Well, when the test is complete, it's going to show you the results here. So it's going to show whether it completed, how many passed, how many failed. It shows a neat project trend line over time, like how are your builds doing, how, really useful for DevOps engineer or just someone who's monitoring the overall health of the test runs. And let's say you want to look into details of what failed, or what passed. You can just click on full report, and voila, it takes you to the AWS console. So this is one of the ones that has, I think, used standard mode. So if you didn't have your test figured out, standard mode's going to do the heavy lifting for you. So let's say you had like 50 tests or 50 test classes. It's going to parse all of your test classes. Then it's going to take one of them and it's going to say, okay, this test class has 2 test methods. So, and then it's going to individually show the video for each run here. And so you can see the video, you can see the result. You also see the logs here, the logs from your host machine, logs from your device, and logs from your actual test execution. Then it also captures performance data for that test execution. So how was your CPU doing? How was the memory doing? What's the thread count there? And then it shows individual logs, like the client log, the server log, whatever the testing framework related logs are there. Now let's check our remote device. How is it doing? There you go. So I have an iPad Air 2, right? So real device, so let's see here. Let me minimize this. It's a little, because I maximized it. There you go. We may have waited too long to come back to this, so let's see. Because it times out. If there's no activity for like 5 minutes, it says I got no input whatsoever. It's going to time out and try and cleanly clean the session. So let's see. Well, we got lucky. All right. So I'm in the Safari browser, and then iPad on the Safari browser. So if you see here, so if I actually click in here, it should show me the keyboard. Hold on. I think my resolution's messing it up a little bit. Let's try that here. With the resolution minimized. There you go. Oops. All right. So, I can say google.com, essentially. Oops. Yeah, I think we waited too long. It completely messed up the session. This is my fault. Let's pick an alternate device and this time make sure that we don't take so much time getting back to it. Yes. That is from the actual device while the test was running. So the question is that how do we get the CPU usage, and is there like something installed on the device? So we try to have minimum interference while your test is running. So the way we get it is multiple ways. So let's say, CPU, like for example. So if the standard tool set for like say iOS provides like, a profiler tool or something. So we run those, we stick to those standard tools as much as possible. If there's something that the customers ask and still is not available, then we try to approach it in a way that it has minimum interference when your app is running. Because if you're testing something and we have something heavy that's going on in the background, it's not the same experience. So we try not to go with that model where something else is running, because then the data is not as you want it, right? All right, so let's pick a private device, more predictable for me. All right, so remember the thing, how can you make test easy, or how can you make test as second nature? So we said CI/CD. Then we said, well, how about Commandline Access or IDE access, right? Real quick Commandline Access. Now let's say you just wanted a device, or just wanted to schedule a run on a device or UC a device. How do you do that? So let's say I have a command line interface here. And I have my AWS SDK and basically AWS CLI installed. All I do is AWS Device Farm, list devices. And if I run that, it's going to give me a list of all the devices that I was seeing in the, in my web browser in the console. So if I say, well, find me an iPad Pro, right? Maybe do -A10. So just like get enough data about it before and after my search. If I do that. So every device type, every device. So here's an iPad. Let's see, where is it? So there's the name of the device in the result set. So this is one object. It's not showing the whole object, but from CLI you can see it has a unique identifier. So let's work from there. So every AWS object, and in this case this is a device. It's a device object. It has a unique identifier here. So I'll say that's the ARN. That's the unique identifier. So I say AWS Device Farm get device -- ARN and that guy, right? So this is my entire device object. So it tells you, well, this is a tablet, that's the name. Remote access, so can you do manual testing on it? What's the resolution? What's the image on that? What's the fleet type? Because it will show you public and private if you have those. And others. So it shows the metadata of your app. So simply speaking, if you really wanted to know, is this device available? All you're doing is going to the command line and saying, yeah, that's available. I should just kick off my run on that one. And you can do all of those things, other things, like, list device pool, say for example. So the way to easily look it up is if you go to AWS Device Farm CLI. So you get a reference here, and that essentially just shows you all the commands that are available for you. So remember all those steps that we did from the console again? All of them you can do it from here. So like a good example would be here. So we have a blog that shows how do you use the CLI. And if you look at it really close, look at it closely. It's like create a device farm project. Command AWS Device Farm create project name. Same stuff we did in console. Create an upload. Device farm create upload project, that unique identifier that was populated here. So you can use those same commands, follow the same flow, and do the whole scheduling, retrieving of the test results from command line. So we also can address the command line access. Now, how do you do IDE access? So Device Farm has a feature that's only for private device, which is give me any device on demand, or give me my private device in demand in my IDE. So there's a feature called direct device access, and that's only available for private devices. I don't think we would have time, but for future reference, it's called direct device access. And essentially, if you want like just a quick device, your private device, to be connected to your IDE, that's the way to go. So it will show up as an emulator, as how you see an emulator screen, but it is a real device. It's your real private device. So the idea would be for people who don't have Jenkins set up is you take all of this as a template. So you take each one of these steps, make a shell script out of it, and then put that as a post-build action in any CI/CD system. So if it was not Jenkins, it was like Bamboo, Travis. All you would care about is this step of device farm should happen after my build. And every CI/CD system almost lets you run a shell script, right? And you can put all of this in a shell script and say, run my shell script after my build is done. So essentially, this just walks you through step by step. But essentially, what you would end up doing for your shell script is copying these commands. So you run it once from your terminal and say, okay, this is my project, this is my device, this is what I need to know, and put that in a shell script, and then put that in the CI/CD system after build, and that's one way to achieve it, right? So the question is, can we query the reporting from here, right? From command line, right? So yes, you can. So there's a part 2 here. So if you look at the device farm commands first, you'll find a few commands in there that says list artifacts, say for example, right? So if I do list artifacts, it's gonna give me all of the artifacts, the file, the logs, the screenshots. And if you had your own reports, it's gonna give you your own report in a format. So it's gonna give you an S3 bucket. So let me show you, that's easier to show. So if I go to part 2 here, so let's say you have your own report. Let's address both cases. You have your reports, let's say for example. So if you say list artifacts, when you execute that command, what it gives you is an S3 bucket, pre-signed S3 bucket URL. It says all your test results and reports are in this S3 bucket after your test is done. And then you just download it from there. And you can use like the S3 command line to just say, S3 CP or S3 sync. And then you can download it. So that's one way. If you need the count of how many tests pass, how many tests fail, then if you look here, if you go back here, let's see. You say get job, and essentially a job is an execution on one device. So if you had 10 devices, you have 10 jobs. So the job will give you the count of what was the test type, what was the status, did it pass, did it fail, how many passed, how many failed, how many errored out. So you can imagine you write this one time where you say, project, get jobs that returns you this, a JSON object, and you write then calls to parse the JSON object to say, okay, tell me how many passed or how many failed. So you have the fundamental building blocks, making a call and getting the JSON object, and then you can just parse that using any, either a JSON parser or just shell script commands, essentially. Does that answer the question?
It does, but I guess if I ran like, say I ran like 20 tests per day, right?
Yeah.
Results from test 15. If I do a get job, would it get the result from job 20, or can I actually specify the job ID?
Yeah, so you can specify job ID. So because when you do the get job, it shows a status whether it passed, failed, or errored, right? And if it failed, then the flow could be, well, if it failed, get me the artifacts, or don't get me the artifacts. So every job also has a unique ID. So if you do a get jobs, then it will say, okay, here's the status on that. So you say, okay, that's the ID. Now get me the count of how many passed, how many failed on this.
I guess because when you use that CLI and you submit the job, right, it seems like it's not blocking, and then it's your ID that you get let's say you have 10 devices that you're testing, right?
Yeah.
Do you get the ID for every device returned, or it's just not blocking, just runs the test, and then uploads to S3, then you don't really know how to reference that.
Oh, got it, I see. So the question is like, how do you reference, once the job is scheduled, how do you get the IDs and how does it know? Yeah. Right, so until you don't do schedule run, which is the official call that kicks off the run, there will be no job ID. So when you do schedule run, the run gets a unique identifier. So the hierarchy is mentioned here. That's a good, I think there's a diagram here that explains it really well, which is there's a run. A run will have multiple jobs, and then the jobs will have suites, and then suites will have tests. So when you do schedule run, which is your starting point, then it will tell you, like, when you say get jobs, it requires a run ID. Like you want to tell it, give me the jobs for this run. Otherwise, it's not going to give you the jobs. No, so as soon as the schedule run call is called, the job ID is generated. You're not. So essentially, this comes down to if you're doing this from scratch on a system that is not supported, then, and depending on the framework that you choose. So let's say you chose the standard framework, right? So standard framework, standard mode of execution. What that does is, once it kicks off a run, until it's all complete, you're not really going to get anything, like the status, the count, or anything, right? So you are only looking at the run. Like I scheduled a run, and you just poll, like, get run. Is it complete? Is it complete? So unfortunately, there's no asynchronous way today on the CLI. So it's all synchronous. So you have to poll and see the job status. The run status. Once that's complete, then you say, okay, run complete, get me jobs. And then you will have to, retrieve all the data with specific calls for the job. So if you had to, if I do get job for, a Nexus 7, right? So if I do, this one doesn't have it, but let's look at get job here. So it's going to tell me whether it actually passed, failed, or skipped, or is it even complete. And then it's going to give me the count, individual counts of those, as we saw in the console in one of the results here. That this is a job because it's a device. So if I go high level, this run has 4 jobs, and then each job will have the number of suites. So these are all your suites, and then each suite will have a test method or multiple test methods. So essentially you're saying job, and then when the count goes, like how many passed, how many failed, that is your actually test methods. Does that make sense?
It does. Let's say I submit some tests.
Yeah.
Submit it, and then 5 minutes later I want to submit some more tests.
Yeah.
And then I submit it. So then, do I just submit the first one and just keep on polling before I submit the second one?
No, so you don't. So the question is, do you have to wait before scheduling multiple runs? So the number of jobs or the number of devices that you can run on, that's really not dependent on the API calls. It's really dependent on how many, let's say, slots you have on your account. So if you had 20 slots, it will run up to 20 devices in parallel. You can schedule 50 runs, What it's going to do is it's going to queue. It's going to say, hey, what's your concurrency? What's your slot count? Or how many private devices do you have? And then it's going to say, well, I see 20. Let's say you have 20 slots. It says, I'm going to go on 20 devices at a time, and the rest are queued.
Okay, but like each time I submit a job,
Yeah.
does it partially fill some of it if I have some slots open?
So the question is, does it partially fill it when you submit a job? So it goes by the device availability if you're using public, right? So you may have submitted the first job. It may have used a device pool that had like 5 devices that are used by all customers right now, other customers. And then you submitted a second job which had the devices available. So if it finds the device available, it's going to go off and get and schedule it on that. Yeah. Does that seems to like, can you think of a use case where that might not be useful, or do you have a contradiction in mind for that?
I want to get the results of the whole job. If it's partially completed, then it might run into a rate condition where some devices are available.
Yeah.
And the subsequent job that was not as available, that's not available in the first job, I mean in the previous job.
Uh-huh.
And then the subsequent job will be more partially finished in the previous job.
Correct. So the point is that if you had multiple jobs running, it may be complete partially on one and not on the other, right?
Yeah.
So because those are separate instances anyways, right? Like only if it could be 2 cases. Either you're running the same test on every device, or the same device type gets picked up, or you're running different tests. In either case, those are different instances of devices. So if they're different instances, they're not going to be conflicting with each other. No, so it's okay. So I get the confusion. So you don't have to poll because there are multiple instances of each device type. So they're all going to go in a multi-threaded fashion. They're all going to say, well, here's one run, here's second run, here's third run. That run may have jobs or devices that are same in all 3. It's not going to contend for that same instance device. If we have one device type, it's going to say, oh, instance 1 found, schedule. Instance 2 found, schedule here. Instance 3 found, schedule here. Yeah.
So I submit this test 1.
Yeah.
So does it have a central run ID or job ID that aggregates the testing for this batch of testing?
It does. So you still have to go. So there's no run level parameter that will say how many tests passed in this run, because run would have job. So you would still have to go. The flow would be still, a run ID uniquely identifiable, identify all the jobs and all its other things. But that's the aggregating factor there. That your run ID is like, okay, this has all these jobs, and
when do I get that run ID?
as soon as you call schedule run. So essentially, let me show you in here.
Okay. So
Yeah.
I call schedule run.
Yeah.
Put in the schedule, can I get an ID?
Yes. So let me show you. Yeah.
Regardless whether the run ID.
Yes. Yeah. Yep. Yes. Sorry if I may have jumped a little bit ahead when I just said schedule run. So let's see here. Schedule runs, right? So let's say you get to the point where you form that device pool, select your devices, and then on the command line you say AWS Device Farm schedule run, and then you tell it what project, what device pool, where's the test package, and then when you say done, it actually schedules and generates this ID for you. This is your run ID. Yeah, so it doesn't. Yeah, I see the point of conflict. It's like, until it gets a job, am I going to get the run? Do I keep polling? Yeah, I think I get it. Yeah, it doesn't wait, because that API call is independent of all other schedule run calls that may be going on. It's going to, yeah. Even if it doesn't get scheduled, because it waits for 24 hours. If it doesn't get the device, it's going to time out. It's going to say, well, I couldn't find anything, it doesn't happen, but still, I mean, there is a timeout. Yeah, cool. All right, so we covered CI/CD. Let's see. So as I mentioned, for Jenkins, the official plugin, you can just go to the Jenkins instance, or it's an open source plugin. So you can just go to GitHub and search for AWS Device Farm Jenkins, and the plugin is hosted there. We do get customers who modify it based on their internal needs, like, oh, I need to have this run tag be placed here on the test somewhere. You can extend the plugin and use it that way too. And then for non-Jenkins CI/CD systems, as I mentioned, you could use this blog as a starting reference point. We do have customers who've done this put this all in as the gentleman was saying that, how do you schedule a run, how do you do that? So you're going to just use this as a flow and then build that shell script and say, okay, make this a post-build action. I think that's what I wanted to cover in today's session. Do we have any questions? All right. Any online questions? Dennis, do we have any questions from online? Okay. We have a question here, yes.
We got one from the online. Is it going to be North Virginia's first, or is it out in multiple regions? I know EKS, when I last looked, was in North Virginia, not in Ireland.
Right. So, so the question is, which regions is it going to be available, and is it going to be available in North Virginia region or other regions, right? Mm-hmm. So, Device Farm as a service is available globally. But the devices are physically located in the U.S. West 2 region. So, any request that comes from any other region, physically the request is going to go to the U.S. West 2 region. So, yeah, we have customers globally that upload their apps, run, but it still runs in the U.S. West 2 regions as of now. So, yeah, there should be no restriction. It shouldn't be like you're in the Virginia region, so you cannot use it. No. Yes, question.
Can you also test device like Alexa and IoT?
Right. So the question is, can we test the IoT devices like Alexa? Unfortunately, today we don't have those devices, but we go by customer demand. 95% of our roadmap is based on customer feedback. But right as of now, we only are focusing on we have mobile devices. So the forums and announcement would be the best place to check. We are hearing requests from customers, but so far it's all mobile devices. So, yeah, cool. Yes. Sorry, I got diverted. Yeah. 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 Right. Right. Best practices, yeah. So the question is that if someone's new to AWS and they are starting right away, what are the resources that they can leverage? Maybe they have testing background, maybe they don't. It's completely new. So pretty much, that's a common theme that we do see when people get started because they want to use the service, they have some expertise, but it all doesn't come together. So you would assuming that you are leveraging at least app build process or app build. So we have Amplify and other things. So even if you were to just do it, write your own app from scratch or start, there are those other AWS mobile tools that you can leverage to just start writing an app. Maybe you don't want to go complex right off, like authentication and other things. And those AWS mobile tools are there to simplify all of these AWS integrations. But let's take it piece by piece. Let's say you're following a Hello World tutorial, and then just you open Android Studio, build your app. Then you want to test, right? And maybe you don't know about testing framework. So we do host sample apps. So if I go to GitHub, for every testing framework that we support, we have sample apps. So if I just do AWS Device Farm, let's say, for example, Appium. So we have Appium test for Android for sample app. And then those tests have extensive comments, and the documentation explains, what this test is doing, where's the source code for each one of this. So like, let's say you wanted to just write a, how do you access a camera in Android? So if I just click on that, it shows this. So this was the instrumentation test, right? So we even distributed by like, what framework are you using? So you can say, okay, camera code, how do you do that? So you can find a lookup that, okay, this is how you access your camera. So like, see, camera.open, camera on display orientation, blah, blah, blah. So if I would go to get AWS samples and search everything with the prefix AWS Device Farm. And that's a really good starting point. So if I just said, if I went here, let's say I want to do Python test, right? So if I say AWS Device Farm Python, and if I say enter, see, sample web app test using Python. So it also tells you how do you test a pure web application. So all the testing frameworks that we support, and yeah, I think you were present yesterday, right? So we also covered the Espresso test. So that's also a resource. If you've never done it, that's a good resource. If you're doing XCUI, say for example, like I showed in the Espresso, there's a recorder. XCUI has also a recorder. So I don't know, maybe I have it here already open. No. while it opens. But essentially, you can record your own tests without knowing much about what's happening underneath. Because sometimes you don't. You just want to record the interaction, put an assert, and that's it, right? So here, I have the recorder here, luckily. So I can maybe go here. Oh, no. Okay, so I can do something like new target, and then UI bundle testing, next. Oh, it already exists? Okay, if you say so. If I go here, so here's my stub that it generates. If I select that and see that, record, and then it's gonna probably open a simulator. So this is like exactly the same way we do espresso tests. Really nice for iOS tests if you already have the iOS source code. It's not just that it was for Android. So you can, again, click here, and it's going to populate the source code over here. And then you can at least look up how do you add asserts, like, how do you add assert in Swift? And that would be the only thing you would have to learn new. So yeah, so let's open the app. It's going to open the app, install, open. The first time, it always takes time. This is why I need an always on access demand device. It's right there. Go. See, it says open. So now if I click, let's say, on inputs. Come on. Click here. Okay, maybe my configuration's messed up, but ideally, it should generate the source code here. Oh, there you go. Now it's catching up. So see that the same way we were doing the espresso test, it's generating those UI interactions. It could be used for even React Native apps. So I've validated this. You can take a React Native app for iOS, use this, and even run it on Device Farm. Works perfectly, no issues. So yeah, any other questions? All right, assuming there's no other online question. All right, cool. Well, thank you very much, everyone.